of z, that is z bar, correct, upon delta z. What is that? Limit delta z tending to 0. Mod of z plus z bar is same as z bar plus delta z bar minus z bar upon delta z. Okay, what is the value? Limit delta z tending to 0. What is this thing? Delta z bar upon delta z. Oh wow. Have you done something like this? Yes, have you done something like this? Or if you don't like, then that delta z, no, delta z को put कर दो something. X plus, yeah, x naught, y naught, whatever you want. Or ab. And have you proved something? If you remember, in limits हम लोग ने एक example लिया था. Do you remember that? Yes. Whether this limit exists or not. What is your answer? And how will you prove if it exists, then how will you prove? And if it does not exist, and then also how will you prove? Do you remember I had done something in limit when I was teaching limit part of this complex analysis? Then I told you this as a definition. I think this as an example. That's for this limit does not exist. Go back and check if you don't remember that thing. Yes. How will you prove this does not exist? Yes. Hey, बोलो. I should ask with someone. हाँ हाँ बोलो बोलो. Yes. Shreyas, your voice is breaking actually. Okay. So suppose if you delta z को suppose I am taking as e plus b. Perfect. Using two path, and what are the two paths? One is real axis and one imaginary axis, correct? Which we had done. Do you agree? Nice. Very nice. I'm happy that somebody answered this. So what is my question now? Limit e plus ib goes to 0, and what is my function? That is e minus ib upon e plus ib. Very nice. So what are the two paths you are going to take? Suppose if limit exists, correct? Suppose if limit exists, then it should exist from all the path. Then it should exist from all the path. So what path I should choose? The first thing I'll put e comma 0, correct? If I put e comma 0, so this limit will be, that is b is 0, so this limit value will be it will be just e tending to 0. It will be e upon e, that is 1. And second, I'll choose as 0 comma b, which is same as bi, correct? So that means limit bi tending to 0, your a is 0, so it will be minus ib upon ib, that is minus 1. So both are different, so limit does not exist. Nice. Since limit is unique, since limit is unique, hence follows. Correct? Do you agree? Nice. Okay. Shall we go ahead? one more function, f of z equal to mod z square. Tell me, what can you say about this function? Start checking the derivatives. What do you have to consider? That is f dash of z, that is equal to limit delta z tending to 0, f of z plus delta z minus f of z upon delta z. Correct? So let us put, so you are having this as limit delta z tending to 0. This is your mod of z plus delta z the whole square minus mod z the whole square upon delta z. What else? How can you solve this thing? How will you solve this? Do you see in the denominator it is delta z? So I have to break this mod and I want to take delta z outside or something. I want to free delta z. That's why I can cut them. Otherwise I won't able to do. I hope you understand. Correct. So how can you go away from this mod? How can you break this? I want in terms of delta z or something. Okay. If you don't remember that, then do you remember this z equal to e plus ib? And what is z bar? E minus ib. What is z into z bar? Yes. What is z into z bar? It is e square plus b square. No, that is same as mod z the whole square. Do you agree? So I hope you understand now what I am going to substitute at place of this. So it will be limit delta z tending to 0. What I will substitute here? It will be z into delta z bar. So that means z plus delta z into z plus delta z bar. That is same as z bar into delta z bar. I hope that is okay to you. And here it is z into z bar. Oh sorry, z into delta z bar. No, that was perfect. No? Yeah, that was perfect. Divide by delta z. Can you quickly open the bracket, and if you divide with delta z, what are the things we are remaining? You will see z into z bar will get cancelled with this guy. So I think the last guy will remain, and otherwise everybody will be okay. That means in somewhere it will be z bar into, so it will be z bar plus, and the next term it will be delta z bar actually. Delta z bar, correct. And next thing it will be plus one thing z into delta z bar upon delta z. Yeah, this one will remain. Do you see which one? Z into delta z bar upon delta. And here it is limit delta z tending to 0. For these two people your limit doesn't matter at all to them, correct? For this one it will be 0 and this will be as it is. What about this one? Can you say something about this? These two people are not at all issue for me. Do you see this one? and whether limit exists for this guy. What is your answer? Yeah. In earlier case, we had done delta z upon delta z bar. Correct? Now, do you see this one? And how will you check whether limit exists or not? Hello. Does this exist? First of all, do you agree this guy does not exist? Do you agree this thing? And how will you prove that if you want to prove this does not exist? How will you prove? So this is something like e minus ib upon e plus ib. Can you again do the same thing जो हम लोग ने पहले किया था? You can go from real axis, then you'll be having 1. If you go from imaginary axis, then you'll be having -1. So do you see ये बंदा तो does not exist है, correct? Do you agree? हाँ मेरा भाई है. हाँ नंबर है. तू क्या हुआ? Hello. Yeah, at least yes, no कुछ तो बोलो. एक मिनट मैं उनका नंबर आपको देता हूँ. एक मिनट. Yes. Do you agree this does not exist? These people, this guy. 9967. That means your delta z bar upon delta z, which is same as I can write as e minus ib upon e plus ib, something like this. And can you prove this does not exist? Yeah. If you go from real, this will go to 1, this will go to -1. So limit does not exist for this guy. Correct? That means can I conclude something? Can I conclude here? अरे यार पावर बैंक को थाने रख दिया मेन बैंक बताओ क्या हाथ वाले बैंक में रखते क्या है? अच्छा यहाँ बता था का? Yes. So this guy does not exist. What about if my z is 0? Then there is not at all an issue. What about if my z is 0? If z is 0, then this will vanish. The part which was making trouble for me, that will vanish. So I don't have any issue then. Correct? So can you conclude something about this function? Can you conclude something? Can you conclude something? Yeah. So the conclusion is this. That means f dash of z exists at z is equal to 0 only. Correct? If your z is non-zero, then does not exist. If dash of z does not exist at z non-zero. Do you agree? Do you agree? Do you agree? Because the part, if I take z as non-zero, then this part will be there, and this is trouble for me. So if this is trouble for me, then this limit does not exist. Correct? And if I want to remove this trouble, I have to make this z as 0. If I take this z as 0, so बाकी case में तो z bar will also be 0 and everything. So derivative will be 0. So derivative of this is 0 once if I take z as 0. Otherwise it is does not exist. Good. ठीक है? And these functions give you an example. These functions tells you something. That means you can have a function which is differentiable at a point, but it is not differentiable in any neighborhood of that. I'll write this from this. From above we understood something, that f of z can be differentiable at a point z equal to xy, but nowhere else in any neighborhood of that point. करेक्ट. डू यू अग्री? जैसे लास्ट में क्या था, आई डिड अ थ्योरम वेयर आई वाज सेइंग कि if function is non-zero then it will be non-zero in that neighborhood, ऐसा something. Correct. And here do you see, here your function is differentiable only at a point, but if you take any neighborhood of that point it won't be differentiable, as I told you that derivative does not exist at any z non-zero, and derivative exists at z equal to 0 only. Correct. So this is what you understand from this. Correct. And one more thing. Yeah, what about this function, whether this is continuous? F of z equal to mod z the whole square, whether this function is continuous. Yes, that means if I write it as x square plus y square, then it is okay. Do you see it is continuous? कोई भी value ले लो, I just have to directly put in the equation. Is continuous everywhere. And do you see this is not differentiable when you take z is non-zero. So this shows you that continuity does not imply differentiability. Do you agree? This gives me a counter example also. Continuity does not imply differentiability, correct? This function was continuous everywhere, but this function is not differential everywhere. It is differential only at z equal to 0. Correct? Perfect, nice. And what about the other way around, whether differentiability implies continuity? And can you prove this if you want to prove this thing? Differentiability implies continuity. Now, if this is not true, then this must be true. So, can you prove this? Proving is that quite easy. Correct? How will you prove? Simple thing. See, you are given limit z tending to z naught, f of z minus f of z naught upon z minus z naught, that is same as f dash of z naught. So this is what you are given with. You want to prove continuity. That means what you want to find this. Alright, consider limit z tending to z naught, f of z minus f of z naught. So you just have to multiply and divide by z minus z naught. So you'll be having limit z tending to z naught, f of z minus f of z naught divided by z minus z naught multiply by z minus z naught. Correct? So this part is your f dash of z naught, and that this is 0. This means that limit z tending to z naught, f of z, which is same as f of z naught. F is continuous at z naught. Nice. Correct. So this was a nice example. Okay. नाउ इफ़ यू सी डेरिवेटिव्स है तो उसके फॉर्मूलेज भी आएंगे. सो डेरिवेटिव्स के फॉर्मूलेज मतलब क्या? अगेन यू टेक अलजेब्रा ऑफ डेरिवेटिव्स. So derivative of f plus g will be f dash plus g dash, and u v u by v सब इसमें apply होगा if your function is in terms of z, हाँ, then only. Otherwise also, but if you are able to find the derivative, then only. Correct? Let me just write derivative of constant, that is 0. Derivative of z raised to n, that is n into z raised to n minus 1. Correct? Derivative of f of z plus g of z, that is same as f dash of z plus g dash of z. And if you find derivative of fz into g of z, then and this is f of z into g dash of z plus f dash of z into g of z. Yes. F of z upon g of z. So what is for u by v? So it will be g of z f dash of z minus f of z g dash of z upon, it is g of z the whole square. Correct? V square, u by v, if you go for u by v, and you can prove that easily. जैसे तुमने रियल केस में प्रूव किया था, everything is same. Proving is same since our definition is only same, so you don't have to worry. And one more, guys, if your f of z is g of f of z, correct, then what is f dash of z? You know what is this called? Chain rule of derivative. This will be g dash of f of z into f dash of z. Correct? Yeah. So till now अभी तक हम लोग ने कुछ भी ऐसा नया नहीं किया है. We are just putting new form, that is in terms of z we are writing. Otherwise everything is same for us. Correct? Okay, let us take an example. Suppose f of z is equal to 2z square plus I raised to 5. Can you tell me the derivative of this? And how will you find? Can you tell me the derivative of this? Yes, what should I use here? Yeah, I'll ask with someone. Rini, can you hear me? Rini? Okay. Remit? How should I find the derivative of this? Yeah. Can you tell me the answer? 5 times it is 2z square plus I, no? Raised to 4. Correct? Multiply by derivative of that. Nice. Good. Thank you. Multiply by 2z square plus I. So that is 5 times 2z square plus I raised to 4. Multiply by, what is the value of this? 2 outside, z square is 4. So it is 4z. So that is your answer. Form में लिख लेना, that's it. Perfect. So do you observe something? When your function is in terms of z, then everything is simple for us, because everything is not new to us. जो भी हम लोग ने किया है सब वही है. Correct? So you must observe this thing. I'll give one more example. I'll ask with you only. Find f dash of z when you are having f of z is equal to z minus 1 upon 2z plus 1, correct? Now you know how to find the derivative. It is in terms of z, so I don't have any issue. Yes, what will be the derivative? It will be by u by v form, correct? Can you complete that thing? Okay, you just have to do by u by v rule, then that's it. Yeah. Okay, nice. So f dash of z is equal to 3 upon 2z plus 1 the whole square. Anybody else with the same answer? You just have to do u by v rule. Is there anyone with the same answer? Anybody else? 3 आ रहा है क्या ऊपर? Two will get. Okay. It is 2z plus 1 v derivative of u minus u derivative of v. So that is 2. So it will be 2 and it will become plus 2. So 2 yeah. So that is 3 upon nice. Perfect. Okay, nice. Yeah. Okay, then I'll stop now.